The lambda max is the wavelength at which a substance absorbs the most light. It's important because measuring the lambda max gives us the most accurate and sensitive results.
The data from the scan gives us a graph that allows us to analyze the spectrum and pinpoint the exact wavelength where absorbance is the greatest, which is the lambda max.
There are two examples for why we scan across all wavelengths. The first example is we scan the full spectrum to ensure we don't miss unexpected absorbance peaks which could irritate impurities/secondary components. Another example is scanning across all wavelengths to help us choose the best wavelength for future measurements, especially in quantitative analysis.
The Beer-Lambert law states that absorbance A is directly proportional to concentration C of a solution, the path length B, and the molar absorbability E. A equals EBC, where A is the absorbance measured by the spectrophotometer, E is a constant that depends on the substance and wavelength, B is the path length of the cuvette, which is 1 centimeter, C is the concentration of the solution. If the machine is not zeroed with a blank, extra absorbance from the solvent or cuvette will be included, making the measured absorbance too high.
First, we have to transfer our dye to our cuvette, so we drop 2 drops of our dye into the cuvette and then dilute it with water until it reaches the fill line, making sure it doesn't overfill with the meniscus. Now we do our spectrophotometer analysis. We clean both sides of the cuvette, place it into the machine, and close the slide door. After that, we have to make sure we zero our machine and set it up from 200 nanometers to 800 nanometers on our wavelength. After that, we finish zeroing, we take our cuvette out of the machine, and we have to clean our dye number 1 before placing it into the machine. Once placed in the machine, we scan across the wavelengths. After scanning across the wavelengths, we collect a graph which displays our lambda max, or the peak absorbance. For this dye, it was 570 nanometers. After we finished our lab, we cleaned up our lab station in this area and in the spectrophotometry analysis room, as well as disposed of all of our materials properly by putting them in designated areas.